equation basically can give you two results. And those results are that the position of any time t, that's what x is related to, so both of these are x, can be given either as a, an amplitude, or just a constant, multiplied by the cosine of omega t, where omega is the angular frequency, plus or b, another amplitude or constant. So, let's see, I've made a mistake here. Here, times the sine of omega t. And here I've drawn these general equations for you. Cosine graph and sine graph, where they're bounded between the positive and negative values of their amplitude, a and b, respectively. But there's two more things, because I did give you a homework problem that talks about velocity and acceleration of these. And in doing this, we have to remember really the algebraic definition, but really look at the calculus definition of velocity and acceleration. So first, what we learned was velocity, and just dropping the arrows for vectors for a moment, change in distance over change in time. However, we could also see velocity as the time differential of the position. And this is where it becomes very important, because if we look at it as the time differential of the position, then both of these are going to give similar yet different responses. So for this, the derivative of this first one, this cosine function, so let me put a velocity of this function over here, this is going to say that it's going to be equal to negative omega multiplied by this a times the sine of omega t. For this one, it's going to give us that the velocity is going to be omega b times the cosine of omega t. So in your books, where they quoted, for example, that the maximum velocity is related to omega times an amplitude, that's what they're meaning here. At the maximum, V max, that means when omega t is equivalent to pi over 2 or 90 degrees,